In this problem, I have two character strings, word1 and word2. These two strings are considered close if they can be transformed into each other by permutations and frequency changes between characters using the following operations. First, swap any two existing characters. For example, A, B, C, D, E becomes A, E, C, D, B. Then, transform every occurrence of one existing character into another existing character and do the same with the other character. For example, AACABB becomes BBCBAA. All A's turn into B's and all B's turn into A's. For example, for word 1 equals ABC and word 2 equals BCA, the first operation is to swap the last characters in word 1, resulting in ACB. The second operation is to change the character A to B in ACB, resulting in BCA, which is exactly word 2. Finally, I will return true or false if the words are considered close. To solve this problem, I will use a 4-step algorithm. First, the algorithm will count the character frequencies, then it will check if each character is present in both words, word 1 and word 2. Next, the two frequency arrays will be sorted and compared. Finally, if all conditions are met, the words are considered close and the function returns true. Otherwise, it returns false. If I were to describe the steps needed to solve this algorithm, I would first start by initializing the arrays that will count the number of appearances of each character in the initial words. Then I would count the frequencies of characters in word 1 and do the same for word 2. Next, I would check the presence of characters and sort and compare the frequency arrays. Finally, I would return my answer based on the comparison of the two arrays. So, let's take the steps one at a time. First, I initialize the two arrays that will count the number of appearances of each character in the initial words. I declared the arrays frec1 and frec2, each of length 26, which are used to count the frequencies of each character in two words, word 1 and word 2. Each position in these arrays corresponds to a letter of the English alphabet AZ. For example, position 0 corresponds to the letter A, position 1 corresponds to the letter B, and so on up to position 25, which corresponds to the letter Z. For each character in word 1, the corresponding value in array frec1 is incremented. For example, if word 1 contains the letter Z, the value at position 25 of array frec1 will be incremented. Similarly, for each character in word 2, the corresponding value in array frec2 is incremented. Next, I need to count the frequencies of characters in word 1. Each character in word 1 is counted in the array frec1. The expression C minus string A is used to map the character C to its position in the array. For example, A to 0, B to 1, and so on. The for loop loops through each character C in the string word 1. The char &C reference is used to directly access each character in word 1, streamlining access and changes. In C++, the ampersand symbol is used to create references among other things. A reference is like a nickname for a variable, allowing direct access and modification of the original variable. In this problem, the ampersand is used to efficiently count and compare character frequencies in the strings. To calculate the index of each character, I use C minus string A, which calculates the alphabetical position of the character C. For example, for the letter A, C minus string A is 0. for the letter B, C minus string A is 1, and so on to the letter Z, where C minus string A is 25. Frec1 of C minus string A++ increments the value from the frec1 array at the calculated position. In other words, the frequency for each letter found is incremented accordingly, keeping a correct record of the number of occurrences of each letter in word 1. Next, I do the same process for word 2. Then, I check the presence of characters. In this step, I use another for loop that checks if the two words have the same letters present, regardless of the number of occurrences of each letter. If a character is present in one of the words but absent in the other, the function returns false. The loop iterates from 0 to 25 to cover all positions in the frequency arrays frec1 and frec2. Remember that each position corresponds to a letter of the English alphabet. The condition checks if the two words have the same letters present. If a character is present in one word but not in the other, the function returns false. Next, I sort and compare the frequency arrays. Sorting the frequency arrays ensures that the character frequencies are in the same order for both words. This makes it easy to compare them directly. The sorting operation sorts the elements in the arrays, ensuring they are in the same order. Using the equal function, I can efficiently compare the arrays to check if they contain the same elements in the same order. Finally, after all these operations, I can return the answer. If the arrays are identical after sorting, the equal function returns true. If the arrays differ at any position, the equal function returns false. In conclusion, to check if two words are close, the algorithm follows these steps. Step 1. Declare and initialize the arrays frec1 and frec2 to count the frequencies of each character in the two words. Step 2. Traverse the characters in word 1 and word 2, incrementing the corresponding values in the frequency arrays frec1 and frec2. Step 3. Check if all characters present in word 1 are also in word 2 and vice versa. If there is a character that appears in one word but not the other, the words are not close. Step 4. Sort the frequency arrays frec1 and frec2. Then, use the equal function to check if these arrays are identical. If all these steps are met, the words are considered close and the function returns true. Otherwise, the function returns false. This algorithm is efficient and ensures that two words are considered close if and only if they can be transformed into each other by permutations and exchanges of character frequencies according to the specified operations. Now, let's test this code and submit it. Remember, you can always try to solve this problem using a different approach that might be more efficient than the one presented here.